Important topic from the junior chemistry, that is ideal gas equation. The ideal gas equation is obtained by combining Boyle's law, Charles' law and Avogadro's law. If V is the volume, P is the pressure, T is the absolute temperature and N is the number of moles of the ideal gas. As per the Boyle's law, Charles' law and Avogadro's law, the derivations are V inversely proportional to 1 by P, V directly proportional to T, V directly proportional to N. So as per the combination of these three equations, you will get the one derivation, that is V proportional NT by P. Here, if you have to removing the proportional, you have to write the constant, that is R. So I write V is equal to R NT by P. So these V is equal to R NT by P are also write PV is equal to nRT. So this is called ideal gas equation. The second important question is state and explain Gram's law of diffusion. Here the Gram's law of diffusion means it states that at constant temperature and pressure, the rate of diffusion of gas is inversely proportional to the square root of its density. So here write the derivation. The rate of diffusion is R is inversely proportional to the 1 by square root of D. At constant temperature and pressure, if R and R1 and R2 are rates of diffusion of two gases and densities are D1 and D2. According to Gram's law, R1 inversely proportional to 1 by square root of D1 and R2 inversely proportional to 1 by square root of D2. Now we have to divisible R1 and R2, you have to write R1 by R2 is equal to square root of D2 by D1. At constant temperature and pressure, the molar value of two gases are same. So you are right, D1 is equal to M1 by V and D2 is equal to M2 by V, where M1, M2 are molecular weight of the gases. So you are right, D1 by D2 is equal to M1 by M2 from equation 1. R1 by R2 is equal to square root of D2 by D1 is equal to square root of M2 by M1. So this is the second derivation. The rate of diffusion of gas is inversely proportional to square root of its molecular weight. You are right, R inversely proportional to square root of molecular weight. The relation between molecular weight and vapor density is molecular weight is equal to 2 into vapor density. So you are right, M1 by M2 is equal to vapor density 1 by vapor density 2. This is the third equation, where VD1 and VD2 are vapor densities of two gases. The rate of diffusion is also inversely proportional to square root of vapor density of gases, that is R inversely proportional to 1 by square root VD. From equation 1, 2, 3, the R1 by R2 is equal to square root of D2 by D1 and is equal to square root of M2 by M1 and is equal to square root of VD2 by VD1.